Mm-mm.
If they were both x, need a cube root to do that. If they were both x cubed on top of one.
If it was just x cubed, but even then you couldn't cancel it like this because you have subtraction right there.
The minus 8 and the multiply by x squared.
Yeah. Mm-hmm.
I have to show you. The part where we did like x minus 1
Mhm.
and then x minus 1 squared, do we do the same thing for just x?
Yes.
On the bottom where it's x cubed, I mean x squared,
Mm-hmm.
would we write that out as a over x and then b over x squared?
Exactly. Yep. That's the part of this I wanted to see if you would be able to kind of extrapolate from the last example. That is correct to start it out. You have a repeated linear factor, squared, so you start out with just a over x, and then you go b over x squared, and then you stop, and then now move on to the next one. Yes?
Yeah, but will C remain x minus 1 cubed, or will that go on?
That's got to go the same way. C over,
C over x minus 1 and e over x minus 1.
yeah, you're going to e.
Squared.
And notice I'm using e like a capital E instead of e like the exponential e.
Yeah.
Natural number.
Because then you're like, oh, it's the law.
Yeah, it's not the same e.
Take a law there.
5 variables, 5 unknowns. Yeah. This makes sense?
Should we factor that top or no?
No, I wouldn't mess with it. Okay, let's do LCD on both sides. We know the top is, this is x minus 8. That's good news. Okay. What's still left when you hit a over x with x squared times x minus 1 cubed?
X times x minus 1 cubed.
1x is still there, and x minus 1 cubed is still there. Plus b. Now this time the x squareds are gone, so you get b x minus 1 cubed. How about c?
It's going to be c times x squared times x minus 1 squared.
Good. X squared, good. Good. And finally, e x squared. Ooh, wow. Not so bad, except for the next step, which may not work out the way you want it to. Can you ever get A with the shortcut? Well, you got to be able to kill all of these off.
In theory, if we were calculating.
What are the only 2 numbers that are going to kill anything off in this problem? 0 and 1. That's it, right? 0 and 1. Nothing else is going to kill any of these off. Agreed? So let's just start by just letting x be 0 and let x be 1. Let's just see what happens. Let x be 0. Let's start with that. Let x be 0. What do we get? Left side of the equation. Negative 8. This? Gone, right? Because of that x right there, that whole thing is 0, we're done.
Yeah.
This one doesn't go away, though. Because 0 minus 1 is negative 1. Negative 1 cubed is negative b, right? So that's good news right there. This one,
0.
gone. This one, gone. This one.
Gone.
Oh, wow, that's nice. B is 8. Well, that's better than nothing, right? Which is what I had before. Okay, now the next thing, let's let x be 1 and see what happens.
So
Who wants to say, no, guys, we have to have a female volunteer. Anyone want to say let x be 1? No? Too shy? Come on. We want a female representative of God here. We don't want to assume God is male. No?
That would be sexist.
No? Okay, I guess God's going to be male here. All right, let me try and do this. Let x be 1. That's good? No? Okay. It's hard to be, high volume female voice.
Like reality, he sounds like Mike Tyson.
Negative 7, right? We're doing 1 cubed minus 8.
My female voice actors are high for female okay.
What about this one?
That would just be 8.
We have an x minus 1 in there. It's gone. It's gone. Gone. Gone.
There you go.
There we go. We get one thing happening here, right? E. E times 1 squared is E. E is negative 7. So we have 2 of the 5, don't we?
Well, we still have a lot more.
We still have a lot more to get, right? We have 3 variables still to get. So
So, I guess we have to multiply that out.
yeah, let's see. If we actually do the multiplication of this, this is going to be pretty ugly, isn't it?
It's gonna suck.
Let's try and do this. Let's replace b with 8 and e with negative 7. Let's just try that, okay? B is 8. Replace this with 8. And e with what? Negative 7? All right, that's better than we had, right? It's better than we had. What I'd like to do now is, because this no longer has any A's, B's, C's, D's, or E's in it, and this no longer has any A, B, C, D, or E in it, I'd like to move those to the other side of the equation.
Just as is.
Yeah, just as in, and I think I'll expand it out once I get it over there, maybe. We'll see. X cubed minus 8 minus 8 times x minus 1 cubed plus 7x squared equals, do you understand what I did there? Took this over, took this over, and all I have left on the right side is a times x minus 1 cubed plus c x squared times x minus 1 squared plus d times x squared times x minus 1. This is going to be kind of messy algebra here, isn't it? I don't think there's any way I can avoid having to expand this out. So what I need to do right now is I need to figure out what x minus 1 cubed is, and then I'll multiply it times negative 8, and I'm going to collect all these terms together. I've got to figure out what x minus 1 cubed is, which is the same thing, right? And then I have to multiply an ax through it. I have to do an x minus 1 squared and multiply a cx squared through it, and then that I can just pass it through, right? So quite a bit of work to do here.
Yeah. Is there any shortcuts or not?
Pascal's triangle, we talked about that
Yeah,
a little bit. But you know what? Look, x minus 1 cubed is really the kind of heart of the problem here. I've got to do that, right?
Yeah.
Okay. So let me just scratch work on the side here. X minus 1 cubed.
Why don't you just do x minus 1 squared, and then you can do the cube later.
Well, I'm going to do it in 2 pieces. Watch. That's what it means, right? If I do these 2 together, that's x minus 1 squared.
Right.
So let's do that. We know that, right? X minus 1 squared is x squared minus 2x plus 1. We know that. Collecting like terms together. So that's what this one's going to be, right? But then we pass this through. So here, 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 and then here, here, here. So you should get x cubed minus 3x squared plus 3x plus minus 1. If you do it. I'm not going to multiply it out. But that's what you should get. All I did was use Pascal's triangle. Remember that?
Something like that.
I'm using this row right here, 1, 3, 3, 1, except for the fact that I had a negative in here. What it does is it switches the signs. But I'm going to expect that everyone in here could do that multiplication, collect like terms, and get to this answer. All right? All right, so let's do this right here. I have x cubed minus 8. I have negative 8 times this, which is that up there. So what happens if I hit this with negative 8? Negative 8x cubed plus 24x squared minus 24x plus 8. Are y'all following me?
Yeah, there's just a lot of math.
I know, this is
It's being yanked.
This is unpleasant, okay, but this is just part of the nature of the beast. I know we want shortcuts a lot, and we try when we can, but when we can't, we are forced to just do the algebra, all right?
That's why they like to use shortcuts.
Do your 8s cancel out? Or no?
Yeah, I'm going to get some stuff to cancel. I'm not real worried about it right now, though. I'm worried more about this side. I've got to do x minus 1 cubed again, which is this, but I've got to pass an ax through it. So if I multiply this by ax, I will get ax to the 4th minus 3ax cubed plus 3ax squared minus 3ax. Do you all agree? That's ax times this. Plus x minus 1 squared.
I need a longer thing.
Is there a what? Minus, oh, no 3, right? What am I? No, this one shouldn't be here. Oh, hold on a second. We're doing ax times this. So ax times this is ax to the 4th minus 3ax cubed plus 3ax squared minus ax. My mistake. All right, next thing. I need cx squared times this, right? This piece is this right here, okay? That's x minus 1 squared. So multiply this times cx squared. So what's cx squared times this?
CX to 4.
Cx to the 4th. What's cx squared times this? Negative 2cx cubed. And what is cx squared times 1? Just cx squared. This is brutal, huh? All right, last one. This one just passes through. So plus dx cubed minus dx squared. All right. I know this seems bad, all right? I know it does, but I have to be truly honest with you. You want to be an engineer, you want to be a computer science major, you want to get into those fields, you actually have to enjoy this a little bit. This happens a lot. I actually yesterday had a student of mine who took me for Cal 2, and she was an outstanding student in my class. And she went on, right now she's doing her engineering degree. She's gotten through like her first, she's like a junior, senior in engineering right now. And I was like, just tell me, like, what can I tell my students, you know, like what's the one thing I can tell them that might help them? And she said, if you're talking to them in like college algebra, pre-cal, you need to just tell them, like, if you don't like this, then you're going to hate it later. Like if this stuff doesn't, if you don't enjoy this sort of grinding out of things, like you're in the wrong field. You have to want to do things like this if you want to be an engineer. I know it's like, yeah, it's tedious and it's a pain in the ass, but there's got to be this party that's like, but I can do it. I know how to do it. I'm going to show you I know how to do it, and here it is, you know? There's got to be that in you a little bit. Okay.
So now combine like terms.
Yeah, I'm just going to combine things together. So let's see. I was told that these 8s canceled a long time ago, and I agree.
3x squared and then minus
I have x cubed and a negative 8x cubed, which is negative 7x cubed. Well, it's x cubed minus 8x cubed, right? So negative 7x cubed.
And then 24, then 7.
So I've done these. 24x squared and 7x squared is,
32, right?
I don't know. No?
31.
31?
I was
Close
close enough.
enough. Ah. There goes the bridge. Yeah, those bolts are big enough. And then minus 24x.
I think those orphans were getting adopted today too.
Hey, there's the drill test.
Took it to the next level.
All right, now put like
All right, now let's do all the fourth power stuff, which is this one and just this one, right? So
C and A.
just a C and an A.
Yeah.
So can I do this? A plus C,
Yeah. Yeah.
x to the fourth.
Yeah, that's
All right, so it's starting to come together, right? I mean, it's not that fun, but
And then the thirds, let's see, there's
negative 3a minus 2c plus d, right? Plus d, so say it again. What is it? X cubed, right? Okay, x squareds. I think I'll circle my x squareds. 3ax squared, cx squared, negative dx squared. So 3a plus c minus d, x squared, and anything else. I really do need to start getting this out of here.
It was just AX by itself.
Ax by itself, minus, right? Minus ax, minus ax. Whew. My goodness. I've got a video of it.
it's on the YouTube.
Then I have to get on YouTube, and then I have to look for it.
Then I have to get out the syllabus and click lecture videos.
I urge you search you on the YouTube.
All right, so what can you tell me about a plus c? What does a plus c have to be? What does a plus c have to be, everyone?
Has to be equal to, pretty regular uploading.
We've come this far. Come on, let's finish it up. I'll let you go right after this problem. What's that?
Is this gonna be on the test?
Yeah, why not? Yeah, maybe not something as involved as this one, but yeah, partial fractions for sure.
So like the beginning, like the simple ones here?
Yeah, like where you, I mean, I think I could ask you a partial fraction problem that would include like solving systems of equations, right? It's kind of like,
shoot ourselves over trying to get done in that amount of time while doing the rest of it.
I hope that you weren't going to shoot yourself for it, but
I think that's
I think that I'm gonna have to cut my fingers over.
yeah.
That's not gonna get.
But if you chop your fingers off, you do.
Yeah,
So
is that still optional?
Exactly.
Negative 7? Is that still optional with fingers?
that is always on the table.
Watch, 1 year he's gonna have a student that's gonna like slip
know.
his fingers.
I'm a little, I don't know, I'm a little concerned
Yeah, actually, and this is the
because this is supposed to be the end of the course, right? So I'm trying to challenge you here with a problem that is more realistic as to where you're headed with mathematics. Trying to give you a taste of, I told you, this is like the beginning of pre-cal, and this is where they're trying to like make sure this is what you want to do. So if you're already like fainting away from this sort of challenge, then you really do need to consider whether or not, I mean, you really want to do this sort of thing, because this is just algebra, right? Nothing. Have I introduced anything new here? I mean, as far as like algebra, no, it's all the same, right? All right, just keep going. Come on, let's finish it.
All right, so.
What does a plus c have to be? What's your x to the fourth over here? 0, right? 0. All right.
Right, because the x to the fourth is.
Because x to the fourth here, there is no x to the fourth here. So I look at it as 0x to the fourth, right?
Yeah, so a plus c.
What's the next one?
So the third.
negative 3a minus 2c plus d must equal negative 7. And then I have what? 3a plus c minus d must equal 31.
You do the same thing with AX.
And then look at the last one.
Negative AX.
Negative ax equals negative 24. And that last one, not negative ax, negative a, sorry.
Put the X in there?
Yeah,
Oh,
no,
I'm sorry.
it's the number in front, right?
I'm sorry.
So that tells me that a is 24. That's good news. I have another one, right? I have 3 of 4 now, don't I?
Yes.
I have 3 of 4.
We have D.
But look at this right here. Just these right here. Isn't that 3 equations, 3 unknowns? Calculator?
Yeah.
Look at your coefficients. 1, 1, 0, 0. Negative 3, negative 2, 1, negative 7.
See, this is where
3,
matrix
1, negative 1, 31.
See, this is where putting in the matrix formula makes sense.
Yeah. Finally, you can turn to your computer or your calculator for some assistance on this.
Didn't we solve for C having A already?
Yes, you could go back and do a bunch of things to go get C, and then once you have C, you go get D, and then yes, you could.
So it's 24, -24,
Okay, so you got 24, negative 24, 17, 0, 0.
What?
I think. Oh, you put all the equations in.
Oh,
Yes,
yeah.
that's okay. That's okay. That's okay because remember these answers right here. When you have your matrix, the answer is 1, 0, 0,
Oh, 'cause the
right?
last one, the
24. Yeah, the last one. This one means A. The second one is B or C, and then the next one is D. All right, so that's A, B, C.
In what
Or
order?
A, D, A, C, D. A, C, D. A, C, D, C. A, C, D, C.
That's how they got it.
That's the name.
They just got tired of doing that.
All right, so let's see. A is 24. B we had a while ago. What was B?
8.
8. Okay, C was negative 24. D is 7, and E is... Oh, wait, no.
Oh wait, no, D was -7.
E is negative 7.
Wait,
D is
What about 17?
D was
no, that's E. That's
because in the
No, D.
oh wait, no, D. No, D. D
Wait,
has
y'all
to be
messed it up.
17. E is -7.
E is negative 7. We found that a long time ago.
yeah,
D
so
is 17.
D is 17.
That was one in the matrix.
Yeah, that was one in the matrix we just got. Yes?
Just said that.
So, the partial fraction decomposition is, final answer, 24 over x plus 8 over x squared minus 24 over x minus 1 plus 17 over x minus 1 squared minus 7 over x minus 1 cubed.
5 pages later.
5 pages later. Yep.
It's actually a page and a half.
That is, believe it or not, that is something that later on in the calculus class you will be happy to get to that point and go, oh, okay, now I can do the problem.
If I don't know what
All right, well, what we'll do, I said I'd let you go. There's some stuff I'm not talking about,
but yeah, I was about to say.
and that's what happens if your bottom is a quadratic that cannot be factored. You know, what do you do then? So I'll ask you, do you want me to show you more of this because you're going to see more of this later, or do you want me to get into sequences and series on Tuesday? You ready for something different? Because you'll be exposed to this again, all right? But you'll at least have the first, I'd say you've got like half of it,
But like in
you've seen like
pre-cal,
half of it.
When we do this in pre-cal, are they going to like kind of go over it again? They're gonna-
Yes, it's not going to be assumed that you've seen it. I'm kind of giving you like a preview of this more than anything else. So you'll actually be happy when you get there that you're like, okay, I've kind of seen this already.
Is this gonna be the beginning of pre-calc?
It depends on the instructor. Usually they like to start with this. Some people skip it though. And then you get to calculus and it's like, whoa.
I know Kirsty, she likes to assume that you already know something.
Yeah, this is not a prereq